All right, we're going to talk about how to evaluate composite functions for specific inputs. And what this means is essentially piping from one function straight into the next one all at once. We'll see what this looks like in just a second. The notation that you need to be familiar with, f of g of 4. That's really just another way of writing f of g of 4, which means plug 4 into g, and then whatever comes out of that, plug it into f. So the way that I'm going to approach this is, first, I need to know what g of 4 even is in the first place. So I'm going to take g, which is defined over there, and I'll say that g of 4 is going to be equal to 4 squared plus 10 times 4. I can do a lot of this in my head. 4 squared is 16, 10 times 4 is 40, which means the whole thing adds up to 56. Cool. So if g of 4 is 56, and I want to find f of g of 4, then what I'm really looking for is just f of 56. And so I'll plug 56 into this function right here, and I get 56 plus 25. And I haven't done this math in advance. Think 6 and 5. I'm going to end up with 1, 5 and 2 is 7, 81, which means that my output will be 9. So if f of 56 is 9, then what that means, f of g of 4 is equal to 9. Because g of 4 was 56, and so f of 56 is that 9. The other thing worth noting is that you can also compose a function with itself. So g of 4 just means take g of whatever g of 4 is. Well, luckily for us, I already know that g of 4 is 56. I just did that work. So let me save some time and remind myself that g of 4 is equal to 56. So g of 4 is just g of 56, which is some exhausting math, because what I realize now is that in order to compute g of 56, I'm going to have to know what 56 squared is, and I don't know that off the top of my head. I do know that 10 times 56 is 560. All right, excuse me while I cheat. $3,136 plus 560 means that g of 56 is 3,696. Composite functions.